Hello, and welcome to this episode. This will be the second one. And last time we learned basically how to set up the program MPLAB and also how to use trace a value and how to display them and how to read them basically. Right, this time now we are going to use a different PIC. We won't use the same PIC that we have on multisim. Instead, we'll use this PIC here, the PIC18F252 or 242. Basically, they have the same diagram, they have the same ports. Now, what's interesting about this PIC over the other one is that it's got RBO, RB0, which is also an interrupt, but it's also a pull-up. It's interesting because this one also has another two interrupts. Interrupt will be something that we'll look into in the future, but for now we don't really care about that much about it. We care that this is better to use for inputs and stuff like that. Yeah, so that's got more ports. It's got RA, RB, and RC, and they are quite big. As you'll see. Now, there's a blank, there's nothing here basically, it's only the void main and the while loop. So we'll get started in. First step, if you remember, and you should, is this configuration here. You can have a look over it if you wish to. Let me just, because I have, there you go. You can have a look over it, see what needs to be changed. Again, don't worry too much about it. What I'll suggest is go here, set it to HS, and then go, I think this one was here, and set it to off. These are the only things you need to do for now. Okay, and oh, doesn't mean do it through here. Okay, I guess we'll have to go to the other method, which is from the top. There you go. Let's see. Simulator was it? No. Configuration bits. There you go. There you go. HS or FF. There you go. Now we generate the code. Here's our code. It's a lot bigger than the previous one because this PIC has more options. So let's see. I think we'll grab it from here all the way up to here. Copy. We go around here, configuration statements, and we'll place them here. There you go. Let's add this one for good measure as well. Why not? Just to make sure. There you go. Alright, now let's pull this one back down. We don't really need it. There you go. And let me move this a little bit more like this. Sorry for the weird angles and things like that, but this way you should better see the code because you don't need to see everything. Alright, now as you know, the next step would be to include the libraries, basically the sets of commands that we can use. So, where would they go? Include files, I think, is it? Yeah. There you go. We have the XC library, study library. Yeah, sorry about that, I keep getting interrupted. Now, let's go to the next step. So, first of all, we set it up, we put the right microchip, which is the PIC, then we put in the configurations, then the library. Now, here's the fun part, which is defining. Now, what do we want to do? Well, there you can see it. What I would like is for me to use this pin here, RB0, as an input pin, something that we didn't do last time. Last time we simply made a command that was outputting values, but we didn't have an actual input. So let's try to make an input. And also, that way that will have an input, this input will control the output, and the output will be here in RAO. Now, something interesting that you can do, but I don't really like to do it in general, is that you can set each pin individually. You can say this one is an output, this one is an input, this one is an input, this one is an output, this one is an output, and it's these three other inputs. You can say like that, this is however you like. But I don't really like to do it like that. I would much rather prefer, okay, I'll use RB as inputs and then RAs as outputs. Now, you don't always have the luxury of this, you don't always have enough ports, ironically enough, to do it. But you know, it's easier to keep it organized and you're not getting confused, because let's say RB4 it's an input and RB3 it's an output, and then all of a sudden you wonder why RB3 is not giving you out values. Anyway, give me a second, my dog is annoying. Alright, so now that we know what we want to do, we want this port here to be an output port and this port here to be an input port. Let's get to the definitions now. So, if you remember how to do a definition, you do the hashtag and then you write define space, then we need to give it a name. We'll call this one set A, and then we also need to tell what port it is. So that will be the name of trace A. Again, trace A, what it is referring to is the entirety of the array port. Alright, now we press enter, and we do the same. We do define, this time we call it set B. Oops, there we go. And this time will be for trace B. Now, this one was selecting the entirety of port B. Oops, I misspelled set actually. There you go. That's a bit awkward. And let's make them even. There you go. Now, what we also want is we want a specific pin. Last time we used the entirety of the port, and you don't always want to do this. Sometimes you just want a specific port. So let's do this again. Hashtag define. This time will be output port A bits dot R, and you know it's right because it's autofilling RA0. There you go, and that's how we call only one port. What do you mean by that? Well, from you might think, what do you need to call trace A? Well, first you need to define trace A, and from trace A, when you refer to output, you refer specifically to RA0, which is this one, pin 2, okay? And we'll refer to RB0 as well, which will be pin 21. And that one we'll call it input. So hashtag define input port B bits dot R B0. There you go. And now this one will be the pin 21 for RB. So yeah, so when we tell the program set A, the program will think of the entirety of trace A. When we say set B, it will think of the entirety of set B. But when we say output, it will think of RA0, and when we say input, it will think of RB0. Okay? Alright. I know it's annoying that you need to set every single port and pin apart, but what can you do about it? And these ones are just the definitions. Now we won't go through the main yet, or the while loop. We still need to do the setup. So actually I need to go up here above it, don't I? I think here it's good. Is it? Let's see. No, wait. Let's put in functions here. So void set up, a simple one, brackets void. If you are wondering why we use these brackets like this, and we put void inside of it, from C language, I know this means that any type of variable or number can be inside of it, being like character, string, integer, everything can be inside of it. I'm not sure why it's a void beforehand, but again, this is how you should code, so that's what I do. Now, the setup function here, we need to write again void space set up. You go ignore the error, is because we didn't write it properly and close it. Void, and this quickly bracket, enter, and there you go. And yeah, there you go. This one disappeared as well. Okay, now here will be the interesting part, and let's see if it works. Is in as I said earlier, in this port here, for example, port A, trace A, we'll need to set up each one of them individually as input or output. Alright? Now, the way you do it is you go to the setup, because it has to be at the very top of the code. You need to start the code with this, and we'll write trace A, basically calling this function here. Or we can even let's call it by the name actually. Let's say set A, because we gave it a name anyway. So let's see here, set A. There you go, and then we'll put equal 0b, and then 1 2 3 4 5 6 7. Is it actually 7? Let me check. So let me put this one up so you can see it. There you go, port A. Yep, there are 7 bits from 0 to 6. All right. Now don't forget the semicolon, that's why the error is there. There you go, now the error disappeared. Now let's go for set B. Set B, and you may think, well, isn't it the same thing? Well, not set B. It's a bit bigger, it's got 8 bits. Ignore what's in here, it's from the previous code. And this one will be 0, B, 0, 1, 2, 3, 4, 5, 6, 7, and then the last one, which will be RB0, 1. Because it's a 1 in there, because of this one, this will be an input. And that's what I mean by setting separately. So it's RB1, no, this one is sorry. So let me see. No, it doesn't like that, okay? Like that? Yeah, there you go. So this one is RB1, no, RB0, RB1, RB2, RB3, RB4, and so on. And that way I can say, like, well, I want RB1 to be an input as well. Well, I just did this and I'll put one here as well. And now RB1 and RB0 are inputs. There you go. And that's how you set it separately. You can also be a bit lazy if you want, and you can be like this, just put all of them to inputs, but we don't really need it. 1, 2, 3, 4, 5, 6, 7. We don't really need to do so. We only need only one input for this exercise or this example that I give you. Alright, so now this one, it's like this. So this one, it's like that. No, I think we need to call trace A, yeah. Sorry about that. Trace A, and then this one will be trace B. Why can I do it? Just this is how MPLAB works, because I realized if I call the function, it will call trace A, but that doesn't mean it sets trace A. To set trace A, to see the ports, need to do it manually. So these ones will make this one's outputs, this one outputs, and one input. Now to make them all like how is it called, when you start the program, everything needs to be equal to 0. Otherwise, it will just be a mess. So now we use the set A, which will be equal with 0, B, 1, 2, 3, 4, 5, 6, 7. Semicolon. There you go. And then set B equal to 0, B, 1, 2, 3, 4, 5, 6, 7, 8. There you go. Semicolon as well. Now, another thing that we need to do, and it's a bit strange for rewriting, it's actually, let me pause and see if I can find the table. Okay, I found what I was looking for. Now, another important step that we need to take when programming is you need to do this. ADCON1 bits, yep, dot P, there you go, it's auto-filling, PCFG equal to 0B0111. Okay, and semicolon, so the error goes away. There you go. And now you'll say, Alex, what does this even mean? It doesn't make any sense. Where's this ADC con 1 bits? And what is this PCFG? And from where did you get this number here? Well, ADC con is analog digital converter, and I think it's for on, like it's actually turned on and stuff like that. What PCFG is, I honestly don't know. I know you're supposed to write this for this PIC after the dot, so you can actually see it as a command. And now the more important one is, from where did I get this number? Well, I have this table here. There you go. I had to pause the video because I didn't have like handy in that moment. And let's see, yeah, I can see it well enough. And you may see like this one is again provided by the university, which is very nice. Right, this like basic port configurations. Now, we did the part with trace A, setting the inputs and outputs. But after that, you also need to tell what type of inputs and outputs they are. And you say, what do you mean what type they are? Well, when you write after this B number, after 0B, you will write one of these numbers. And what these numbers tell the program basically is this. If we wrote actually take this as an example, it's better. If we were writing 00110 after B instead of 0111, then RA will be a digital either input or output depending what we set it up here above. It will be a digital signal. Then RA will be an analog signal. RA4 will be a digital signal, and then the rest of them will be analog signals. Because we used 01111, which will basically be this one, the X means it can either be 0 or 1. Then that means that everything, all the pins of the port, they are digital signals. Okay? Alright. So ADC con 1 bits PCFG. Now, I think you really need to do it only for the first one. You need to do it for the other ones. Yeah, I don't really know how to do it for the other ones, so you should work like that. We'll look later in another lessons when I actually learn more about it. But yeah. Okay, now that you understand this and you understand from where I got this number and I will put it here. Basically, we are telling that all the outputs will be digital outputs. I don't even think we need to worry about the inputs if they are digital or analog, because even if it's an analog input, it will still send in a high signal. Now the last one that we need to do, which again I don't really know how it works, but I guess it's for the inputs. It's int con 2 bits dot RPPU equal 0. Oops, that's not 0. Now, what this one means, it's int, I'm pretty sure it means interrupt. Con2, it means from the second port connection to it, maybe something like that. I'm not sure about the con2. And the RBPU, it means registered port, RB, no, the register B, and then pull up function. So basically, it will pull up from when it's activated. And because I said it's equal to 0, basically this one will enable it. Now, again, I'm not 100% sure how it works. I know how a pull up works. The basic concept is that you have a resistor and then you have an empty wire or with a smaller resistance. And the principle is if the signal, there's no endpoint, if there's no ground through the smaller resistor or the signal is 0 and it blocks it, then the current will go to the bigger resistor. But when the signal is back on and it's a ground method to go through, then the current will choose to go through the resistor with less resistance. And basically that's the principle of a pull-up. And in this microchip, in this IC, they don't tell you here in this diagram, but the RBs, they all have pull-ups, they all have resistances to here. Yeah, let me check. I think it's a bit higher here as well, like something that shows it. Or maybe no, it's not on this one. Okay, that's fine. I don't want to show too much because then maybe the university gets mad at me or something like that. Okay, so now this is the setup. So in the void made, let's see, initiate function if you setup. Okay. I guess we'll put it here. So what we need to write, it's simply this setup, set up, bracket, semicolon. Basically, we are calling this function to come now. Alright, we can test the code actually. I don't think that's a problem. So let's build it. See if we get any errors. We didn't get any errors, which is a good step. Program is initializing. Let me see here. Oh no, was it recording till now? Yeah, sorry about that. It was recording actually. I just have these flashbacks basically of me not actually recording and just speaking to like a black screen or something like that, especially since I didn't really record with OBS before. And yeah, but anyway, so now we run it, it's running, so we'll just pause it for a second. It will just stop at a random point because the while loop is empty, so yeah, there isn't not much. So it's telling you when it started, now it stopped. Now into the OS view, there you go. So both of them, port A and port B, they are completely zero. If you remember from like a few minutes ago, port B had some values left over from the previous codes. Now, if you go to the pins iOS, oh yeah, I guess I can show you how to use it, set up. Now, this one's basically it allows you to control the pins. Oops, sorry, I didn't mean to do that. So then, let me delete this. What we want to see is we want to see the pin R, there you go, RA0. And what it's telling you is this one, it's a digital output, the out, yeah, it even says there in the bracket, and it's got the value of 0. Now, if I want to change it to 1, it may show you here 1, but actually it didn't change, it's 0, it's an output. I'm not allowed to change this one. Now, if I put here RB0, there you go, digital output, it should be an input. I wonder why it's in output. Let's try it for a second, stop it again. Yeah, something is not right here. What if I set this one to a 1, 2? Let me stop the program, build it again. It shouldn't be an output, it should be an input. And that's very, very strange. Okay, I'll pause here a second, I'll check out what the problem is. It's really annoying since this thing is making me problems. Because I didn't change anything, I just keep stopping the simulation and starting again, and then all of a sudden it starts working again. Literally, I changed nothing. So I don't know. Anyway, so now if we pause it, because there's no breaking point. Oh yeah, there you go. There you go, it changed back to output for some reason. This is so strange, isn't it? I have no idea why this is. Okay, so let's keep going through it. Let's see, maybe if we put a breaking point it will work. So now I have this a little bit of code in here. So because I can't be bothered to like write it, and it's just some basic if statements because we can actually use C language while programming in MPLAB. And basically what will do the program, for now it's very, very simplified, is that if port RB0 is equal to 1, basically a high, then we'll set port RA0 to 1. So when the input is 1, the output will be 1. When the output is when the input is 0, the output will be 0. So basically that's the code we want to do. Let's put the breaking points, one here and one here, and run the debugger. There you go, run successfully. And no, this is so strange. Both of those are zeros, but this one it's an output mode, even though I set it to in input mode. Let me get rid of this too, maybe. There you go. I'll pause it and I'll rerun it again. Oh, there you go, it works now. Okay, I guess this. Wait, does it actually, or I hope it does. Anyway, so yeah, we set the input RB, it's a 1. Now theoretically, because of this if statement, if the input is equal to 1, it's a 1, then we'll set RA0 to 1. So when we press continue, and there we go, RA0, you can see it here, it's 1. And then on this if statement, if it's 0, the input is 0, then RA is 0. But because the input is not 0, then it will just keep it and say like that. However, if you change the input back to 0, and you can see because it says digital input, the in, you can just change it to 1 and zeros. There you go. And then it's at this if statement. When I press continue, the output should be 0 as well. And there you go, it's 0 as well. I think I messed it up because maybe it overwrote. Maybe I was wrong and I can actually use these values here to say if it's an output or input. I'm not sure. Okay, but I still want them to be equal to 0 when it starts. So I'll write output equals 0. Okay, so output equals 0. There you go. So it will always, RA will always be equal to 0. You can't really change the RB from the commands because, you know, it's an external force. So if I leave it at 1, or even if I leave it at 0, and then I stop the simulation, I restart the simulation. There you go. I got the pins. It remembers that's a 0. So yeah. Okay. Now, you may say, well, this is everything. Well, it's not. I want to show you that we can do different things. Because again, what I worried so much at the beginning was that I thought I had to use only assembly, that MATLAB doesn't understand C language properly, but no, apparently it does. Now, you don't have to say port bit RB0. This one, in case you don't want to define it. Oops, sorry. Let me just go back. There you go. In case you don't want to define it. So I'll stop it for a second. There you go. What I can do is I can say, oops, RB0 is actually input. There you go. See, input, and then this will be output. Output. I can just use the defined values. Now if I run the simulation again, oh yeah, sorry, I need to get rid of these dots because it doesn't really make sense. It doesn't make sense for the program. That's my bad. Sorry about that. There you go. I was rushing through. Now it should work. Shouldn't be any errors. There you go. No errors. So now if I go to the pins, RB it's a 1. RA reset it to 0 because that's what we taught it to do from the setup, to reset it to a 0. Now we press continue, and there you go, set it to a 1. So it works this way too. And you can do like lots of interesting things like this, you know, with the ports. Instead of doing like last time when we set up the entire thing to be equal to like 001, 001 and stuff like that. Now we can just set each one of them to do a specific task in a specific situation. Okay, all right. Another cool thing we can do is we can make it equal the reverse. So it might be a bit strange. So you do the squiggly line, you write output. There you go. And let me copy this one, copy and put it in here as well. No, let's do it the opposite of the input. Actually, I want to see if that works. Input in this as well. Input. So by the logic of this, when the input is equal to 1, then the output will be equal to 0. And when the input is equal to 0, then the output will be equal to 1. So for right now, nothing changed because we didn't press the continue. Still, oh no, wait, I need to rebuild it actually. There you go. Alright, it's set to 0. This one it's set to 1. So nothing should change. Yeah, nothing changed. Now, if we set this one to 0, then the out will become a 1. There you go. Now, what this one does, what this means, it's an MPLAB assembly thing from the PIC. Basically, it's telling you to the opposite signal. So, if this one is a 1, it'll tell you the opposite of this one, which in our case, this one is a 0. So, this one will become a 1, and so on. Pretty cool, pretty neat to be honest. Let's change it back to a 1. There you go, that's changed to a 0. So, let's do a quick recap what we learned today. We learned how to set the ports, the output ports, basically, if I can bring it up again. There you go. Basically, we learned how to set them up on digital values and how we can set them to digital analog or even put like voltage references in there and stuff like that. Okay, what else we have learned? We learned about the pull-up. We didn't learn too much about it because I don't really understand it that well. Because okay, I'll show it to you why I don't understand it. It's indicated to put the pull-up in here. However, if I simply deleted it and build the code and it's running, there you go, and I'm going to this ones and I say this will be equal to 0, so go here, the code will still work perfectly fine. I don't really understand what the purpose of the pull-up is, because it doesn't really make much of a difference. I don't know. I suspect it's a technical thing. It's something that you put because the actual physical chip needs, but the simulation doesn't really need it. The simulation doesn't have the requirements for this. But what else we have learned? Well, we have learned how to set up inputs by basically putting the 0 for output and then 1 for the input value. We already knew how to set a port or an entire trace to a value of 0, but if you want to do it, there you go. You just make the output low, that specific pin low. Then we also learned to use if statements. Actually, another thing that the purpose of the original one was to like make it equal, right? So I guess we can write it also like input equal out. No, wait, sorry, the other way around. Output equal input. There you go, semicolons, done. There you go, I need only one. Actually, let me stop it. Again, this is more like C language now in the while loop, because basically you can make it as short as you like, because like our original intent was for RB0 to match, no, for the input to match the output. So now if you put a 1, you press continue, there you go, now it's perfectly matching. Nice, isn't it? I don't know, think of define as like setting up integers in C language. That's an easier way to understand it. Basically, we say, I want to set up, I want to give this name to this part. Now, maybe we can think about it this way, because definitions threw me off a little bit. I didn't really understand why I use them. Alright, so that will be the video for today, and I'll see you guys next time then. Bye.